Hello, friends and followers. Here's an update on that program I've been using to control the Tec Paragon I. So this is via RS-232. I'm using this interface here, which I got from a gent who sells these cables in Campbell, California. And this is on Mac OS, so I'm using a Mac computer here for this. Anyway, I'm opening this thing at 1200 baud and no timeouts, no parity, nothing. It doesn't run with any X on, X off. There's no RTS, CTS. It just runs and you will send it some delays, timing delays, some sleep delays to make it not mess up. So that's what Tec said to do in 1983. So I wrote a few little functions here. The first thing we do is we want a set frequency function, and this will simply set the frequency to whatever you call the function with. You could put in 7 for 7.0 megahertz. You can put in 28.321, anything you want. It'll set the frequency of the radio to that frequency. So that's how that works. And then this little character here will tell the radio to tune up. So basically that little character there tells the radio that it wants to tune up or turn the tuning knob to the right clockwise to make the frequency increase by the step size. So here I basically have written a status, a bunch of status, I would say, masks. These are bit masks to figure out if certain lines are turned on and turned off. So you can basically query the radio and see if all this stuff is running or not, or buttons are pushed. And I wrote a little status routine that will query the radio and test all these masks and then put out a JSON rendition of what it found. So here's the step sizes you can use on the radio. I'm using this default one of 10 hertz right now. And I return everything the radio can return in status. I can return all this stuff like the tag, the month, date, hours, all that stuff gets returned. And this function here is for getting the status of the radio. So I keep a dictionary called LED and it's empty. This command in Python will send the status command, which to get status, you'll find it's a slash. To send a slash in Python, you're going to put a double slash in there. You send it, everything as a byte. So I sleep, and then I read 30 bytes, because 30 bytes is what it sends back. Sleep a little bit, do a flush, make sure it's all arrived. And then we'll turn this thing into a byte array. And a byte array is simply an array that I can access each byte from an index or an offset. So byte 0, byte 1, byte array 2. So here then I'll go through the array and I'll start, say, getting the frequency in the first, I think 7 bytes is a frequency. So we'll build that into a string. And then I test all the lines. So starting at I guess this is offset 7 in the array, we can start doing AND operations on these bit masks here and get all this stuff figured out to see if it's set. And if it's set, we'll simply change the dictionary. I have a dictionary called LED. So we'll just change this dictionary to say if, say, LSB is off or on, CW off or on. So that would correspond to the lamps on the radio. So those lamps there would basically indicate what is lit from this status command here. So here we'll look at the filters that are turned on or off. And this is all the documentation that Tec gives you. So I just simply read the documentation from 1983, which goes with the old IBM PC from 83. This was all written in a basic program that Tec had. I didn't even muck around with that. I just took the information on the left here and tried to get this Python program to work. And I don't even do all the stuff they do in here. I just generally want to get status out and make sure I can read status. This might be a nice platform for someone else to take it on. And I can read the offset and the status, the offset, TX or RX offset. What else do we do here? Get the time, minutes, seconds, and make a time string from that. Frequency, date, time. And then we return this dictionary. So the status command returns this big dictionary. The dictionary can get read. And then I got a few helper functions in here. Set the mode of the radio to FM or AM or whatever. And that's all right here. So you can see that we're just sending characters to the radio for FM, AM, LSB, all that stuff. That's all done right there. So this is real simple stuff. So now I want to scan the bands. And to do that, I want to first of all figure out whatever tuning we are set to. So whatever tuning step we have, 10 hertz, 100 hertz, 200 hertz, 500 hertz, whatever we're tuning in hertz, I want to first of all get the status of the radio and then figure out what my tuning step size is. This could be the 10, the 20, the 100, whatever. And then I basically find out, okay, what's my bandwidth of the band I'm working with, and I will convert that to hertz. Once I'm in hertz, then I will take this bandwidth and I will divide that by the tuning step, and that'll give me how many steps I need at whatever step I'm set to. If I'm set to 10 hertz, this number will be higher than if I'm set to 20 hertz or I'm set to 50 hertz. This number will be lower for steps for the band, and so I return those steps. And now we have simply band scanning routine. So this thing, like say to scan 80 meters, we know we want to be in LSB. The band goes from 4.0 to 3.5 or 3.5 to 4.0. So I'll set the radio to 3.5 and then I'll sleep while it does that. And then I'll do a scan band, and I'll scan the band with these tuning steps. So I'll do a scan band, and scan band is here, and it's real simple. It just takes the steps and it goes from a range of 0 to steps, and it simply does a tune up. And tune up just basically sends that little bracket. So that's how that works. And for 60 meters, it only has channels, so we just set the radio to these channels and we sleep and see if we hear anybody on USB. For 40 meters, we go from 7.0 to 7.3, start at 7, and we simply do the same thing. We scan through the band. Same thing with 30 meters on USB. There's how the band starts and stops. Same thing on 20 meters, start at 14, go to 14.35. 17 meters is very small, do the same thing from here, 6.8 to 168. We start there and scan. 15 meters, do the same thing. 21 to 21.45, start at 21. 12 meters, 12 meters is here. It's a very small band. Same thing for 12, very small band. 10 meters is very large. We'll start here. So for these bands, you might want to put in a larger step size to go through them more quickly. Anyway, so at the very end of this thing, I can do this stuff all day. So while true means it will keep cycling through this loop all day. It'll start here at 60, go to 40, go to 30, go to 17, go to 10, and it will just keep doing this and doing this and doing this and doing this and doing this all day. So then to run this program, I can stop it right here at this little stop key. And if I run the program now with radio, it'll start at 60 meters, go to 40, go to 30, and I'll show you what it does. So this stuff here, let's see, what is this stuff here? This shouldn't be in here. Let's get rid of this stuff here. Out that goes. And now we can just run the program by starting at 60 and going up. Let's do that. Let's save the program. Okay, now I'm gonna run the program right here. Watch the radio when it runs. Here it goes. Now it's going to start scanning on 40 meters, and it'll go through the entire band. And so now I got to get the step size in. Right now it's stepping at 10 hertz. I should probably make the step size selectable and settable, which I don't have that working yet. And then you can go through the bands more quickly if you want. So you'll hear, sideband and CW, and you can just make note. In fact, I could probably set the squelch on this thing. And that way, if I hear something, it might unkey the squelch and you could make note of what's going on. So that's the plan. I like listening and monitoring when I'm working, but I don't want to be actually interacting with the radio because that takes time. So I'd rather it do its scanning on its own. And if it hears something, let it stop. Well, it won't stop. I have no way of stopping it really. If I hear something, I gotta manually stop it, and that would be interacting with the computer. So this radio isn't smart. The Omni 6 will return an S meter reading, which you could probably read to stop the radio. This one has no way of returning that. And I don't know how I would do that really to stop it. Anyway, hasn't found much yet. I don't see any nets on here. There's usually some stuff going on 40 with nets all day. But I could set this thing to start it at, say, 7.2 and scan to 7.3. That's really easy. In fact, let me show you how that would work. So if you want to change the 40 meter scanning, it's easy. You would just go up here to the 40 meter function or definition on 40 meters, and you say, oh, the band goes from 7.0 to 7.3. I say, no, start the band at 7.2. So there you can go to 7.2, and you can just scan 40 by commenting out these here. Just comment them out. And then it would start at 40. So I'll stop the program, and I will now run the program once again, and you'll see it'll start at 40 meters on 7.2, and it will go up 7.3 most likely. Oh, I set it on 7. That was a mistake. So let's go back to 40 here and see what I did. Okay, so I want to start it at 7.2. I didn't really get that right. There we go. That'll get it going. And I'll just run the program again. There it goes, 7.2. Now I have the squelch on here a bit, so if there's a net or something, I wonder if it'll break squelch. I guess I could try it. Okay, there we go, more volume. Let's see if we hear anything. There's always somebody yapping around here somewhere. I don't see the meter moving. So we're on LSB. Not much going on there, huh? There's always nets on 24, 25. Oh, can't say it's picking up much. So for giggles and grins, let's try 18 because the band is very short. Let's try this. So that band is not very active. If we go down here and just scan, which one is it? Let's go and scan 17 meters. So we capture this one, come down here and say we want to scan 17. And the rest we don't care about. Comment those out. This would scan 17 now. And that's it. Let's stop the program. Stop it right there. Now we're going to start it. And let's see what happened. Well, that's 17. I didn't want that one. Let's scan the next one down. Let's see, 40, 30, 17. Guess I want to scan what? 17 meters. Should be that one. Scan 17 is 18, 18, 18. Scan 17 meters. Not sure why that happened. It's not scanning 18, it's scanning 10. Okay, so I set it to 18. Well, that's not working too well, is it? Okay, so while true, scan 17 meters. And just try it like that. Is there anything else this thing's doing weird? Shouldn't be doing that. Stop it. Start it. Okay, now it's working, right? I'm not sure what happened to it. That's where I want to be. Scanning in 10 Hertz increments. Let's set the squelch. Yeah, there's not much going on. But that band should scan pretty fast. It's a very short band. FT8. So the squelch will break. I'm not sure if it'll break for SSB. Seems like it should. How far does this band go? It goes a little while here. Let's see, this one goes to 18168. 18168. And then it's gonna start over. Start over from 168. Let's see if that works right. Should. Yeah. Anyway, so that's how I could scan this stuff without touching the radio and without having an advanced radio like an IC 7300 or whatever. Using a 1983 boat anchor. That's life in the big city here. Okay, thanks for watching. Have a great day.